All right, guys. So I'm here now to help you with your Unit 8 final exam review constructed response question, aka open-ended questions, aka problem-solving questions. So you will see here that pretty much every single constructed response question for Unit 8 is basically complete and balance this chemical reaction. And the reason that I'm asking you to do that here is because on the final exam, you will essentially just be doing that uh, for the constructed responses, right? This is a good summation of if you understand the content or not. Can I give you two reactants and you tell me how they combine and write the complete and balanced equation? So I'm going to do this. I did not leave you enough room on the final exam packet to do these open-ended problems, so don't try. Have a separate sheet and work it out there. And that's what I'm going to do for you now. So I had a spare sheet here, all right? And we are going to solve some of these problems. Here we go. So problem number 9. Okay, so problem number 9. We need to figure out what happens when you combine sodium and oxygen. Now, first of all, I can tell that because these are two single elements here combining together, that this is going to be a synthesis reaction in which two elements come together to form one compound. So we got a compound here made from sodium and oxygen. But what is the formula? Is it NaO? Is it NaO2? Is it Na2O? The only way to figure this out is to crisscross, all right? These are both ions. Sodium forms a 1 plus ion. I know this because sodium is in the first column of the periodic table. Right? It's right here. All right, there's sodium on the periodic table. It's going to be +1. All right, and you're also going to have, let's see here. Can I find it? One moment. Here it is. You're going to have your common ion sheet attached to your periodic table, and you'll have reviews of what the ions are here. Don't rely on this entirely. Be ready to identify the ions from a periodic table. Okay, so we've got sodium, which forms a +1 ion, oxygen, which forms a 2 minus ion because oxygen is in the this column right here. These are all -2 ions, -1 ions, no charge. So oxygen is a -2 ion. So sodium is +1, oxygen is -2. They come together and form Na2O. Okay? This makes sense. If sodium is a +1 ion and oxygen is a 2 minus ion, then you are going to need two sodiums to cancel out the charge of a single oxygen. Okay? Another way to think of it is again like this. Sodium is a 1 plus ion. So if you've got two sodiums that are each 1 plus and an oxygen that's 2 minus, that's it. They've balanced out. All right, this oxygen will cancel out the charges from both of those guys. All right, now last step is we need to balance this equation. We've got one sodium here and two here. So we're going to have to put a 2 in front. We've got two oxygens here and one here. So we're going to have to put a 2 in front here. But now we have not 2, but 4 sodiums. 2 times 2 is 4. So we got to change this over here to a 4. And this is the complete synthesis reaction. Okay, there we go. Let's go on to the next one. Okay, all right, here we go. So the next problem, H2O reacts. Okay, so this right here is a decomposition reaction because we only have one reactant going in, water. And the only thing it can do then is break down. It's going to break down into H's and O's. But you hopefully recall from your notes that hydrogen and oxygen are both diatomic elements. They are so reactive that they cannot be by themselves. And so if this hydrogen can't find anything to react with, it will bond to another hydrogen. And if this oxygen can't find anything to bond with, it'll bond to another oxygen. All right, and now we balanced. Two hydrogens, good. One oxygen, two oxygens, so I got to put a 2 in front, which now gives us 4 hydrogens, so I got to put a 2 in front right there. Very good. And this is the second reaction. No crisscross needed. We weren't making a new ionic compound. In fact, we were breaking up an ionic compound, so we didn't need to use crisscross there. All right, on to the next one. Ag2SO3, so silver sulfite, and sodium chloride. Okay, this is a double replacement reaction. Let's jump into it. So we've got Ag2SO3, okay, plus NaCl. Now, the first thing I do here is I like to go through and identify what ions are present, right? Just like I identified that sodium is a +1 and oxygen is a -2, I know that silver forms a 1 plus ion, and sulfite, SO3, forms a 2 minus. If you're not sure how you're going to remember that, remember, you will have your common ion sheet here to help you, all right? Hey, here's sulfite, 2 minus charge. So maybe familiarize yourself with this sheet, okay? Then over here, sodium forms a 1 plus charge, and chlorine forms a 1 minus charge, okay? So those are the ions. Now, in a double replacement reaction, ions switch places to form new compounds. Now, the silver is going to go and bond with the chlorine because silver is positive and chlorine is negative. An ionic compound has to have both a positive and a negative. And the sodium is going to go and combine with the sulfite. All right, so here we go. So silver is 1 plus, chlorine is 1 minus. You don't even need to crisscross it, okay? Because they cancel each other out. So the first thing you're going to form is AgCl, okay? And the next thing you're going to combine is sodium, which is 1 plus, and the sulfite polyatomic ion. So you're going to need 1 sulfite and 2 sodiums. So the formula for this is Na2SO3. All right, good. And now we just have to balance this thing. Let's see here. We've got 2 silvers on this side and 1 over here, so we're going to put a 2 down. Okay. We've got 1 sulfite, SO3 is 1, and 1 sulfite, so that's balanced. We've got a sodium here and 2 sodiums here, so we've got to put a 2 in front. And that's balanced. Okay, so this is it. Well, almost it. Because you might recall that for a double replacement reaction, in order for it to occur, one of the products needs to form a solid, liquid, or a gas. So we have to look at silver chloride and sodium sulfite and see if either of them form a solid, liquid, or gas. So I am going to consult, let's see here. Where is it? Ah, here we go. The solubility table. You're going to get one of these, by the way. So let's see here. We had sodium sulfite. Let me show this. Let's see here. Okay, so let's see here. So sodium sulfite. Well, sodium doesn't form precipitates with anything. So sodium sulfite isn't going to give us a reaction. The other thing produced was lead. No, it was silver chloride. Silver chloride. So let's see here. Here's silver and a silver chloride right here. So silver chloride does form a precipitate. So this reaction does occur because silver chloride right here forms a precipitate. So there you go. So that is problem number 11. I'm going to break this up into two parts, and I'm going to do another part right afterwards.